Did you know that science tells us life on Earth has less than a single billion years remaining? That sounds like an eternity, but compared to the 3.5 billion years life has already existed, it's shockingly short. So what will finally bring about the end of all life on our world? Will it be an asteroid strike, a global nuclear conflict, or a colossal natural disaster? Indeed, any of those scenarios could wipe out vast amounts of life. But here's the crucial point. They are all possibilities. They might happen, or they might not. And even if one did, life could potentially recover. There is, however, one conclusion that isn't just a possibility. It's an absolute certainty. Nearly every source of energy on Earth, with the exception of nuclear power, originates from the sun. Every plant, every animal, every breath we draw is sustained, directly or indirectly, by the sun's light. The logic is simple. Life on Earth can persist only as long as our sun continues to shine. Now, you might assume this means we are secure for a long time. After all, scientists estimate the sun still has another 8 to 10 billion years of fuel left. But there's a catch. Long before the sun actually dies, in around 5 billion years, it will expand into a red giant so huge it might swallow Earth. That might sound comforting. 5 billion years is a long way off. But the truth is, life on Earth won't last anywhere near that long. In fact, every living organism here will vanish long before the sun becomes a red giant. Compared to the time life has existed, the remaining window is alarmingly brief. And what exactly will cause life to disappear so much sooner? That's what we'll explore in this video. Hi friends, and welcome to another episode of Space Science Simplified. Every star is surrounded by a region known as the habitable zone. This is the special distance where temperatures are just right for life. Not too hot, not too cold, so that liquid water can exist on a planet's surface. If a planet is too close to its star, it's scorched. Water would boil away into vapor. If it's too far, it's frozen solid with water locked as ice. This ideal, just right region is often called the Goldilocks Zone. For our Sun, the habitable zone is currently estimated to stretch from around the orbit of Venus to that of Mars. Earth sits right in the middle, which is why it has been such a good home for life. Venus is near the inner edge, and Mars is near the outer edge. But here's the critical detail. The habitable zone isn't fixed. As stars age, their energy output changes, and the zone slowly drifts outward. Billions of years ago, when our solar system was young, the sun was dimmer and cooler. Its habitable zone was much closer. Back then, Earth sat at the far outer edge of it. Venus was inside it, and Mars was well beyond it. Over billions of years, as the sun's brightness increased, the habitable zone moved outward. That's why today, Earth is right in the middle of the sweet spot. Venus is now at the very edge of being too hot, and Mars has just slipped into the cooler outer edge. This outward drift happens to all stars, and eventually, Earth will be left behind as the zone continues to move away. Like all stars, the sun runs on nuclear fusion. In its core, hydrogen atoms are squeezed together into helium, releasing unimaginable amounts of energy. But here's something fascinating. This doesn't happen throughout the whole sun. It only happens deep in the core, where the pressure and heat are extreme enough. The sun is enormous, about 1.4 million kilometers across, but all the power that lights up our solar system comes from just its innermost fraction. Imagine a single glowing bulb hidden inside a giant lantern. Yet somehow, it powers an entire planet. That's how concentrated the sun's engine really is. Fusion slowly changes the balance inside the sun. As hydrogen turns into helium, the helium sinks and packs tightly into the core. This makes the core contract under its own gravity, which in turn raises the pressure and temperature even more. Think of it like a pressure cooker. You're squeezing more into less space, so the heat builds up. As the temperature climbs, fusion speeds up, and the sun shines brighter. When the sun first formed, it was about 30% dimmer than today. Over the past 4.5 billion years, it's been steadily brightening. And it's not stopping. The brightness continues to rise, currently at about 1% every 100 million years. Like a thermostat being nudged higher and higher, the effect might feel slow, but it's relentless. As the sun grows hotter, its habitable zone will shift farther out. Eventually, it will pass beyond Earth's orbit. When that happens, Earth will no longer sit in the comfortable Goldilocks zone. The heat will become overwhelming, and global temperatures will rise beyond what life can handle. our oceans, rivers, and lakes will start boiling away. Earth will become a dry, barren wasteland. For a while, some life may cling on in underground pockets of water, but even those won't last. As the heat intensifies, every drop of water will vanish. As water evaporates, the atmosphere will fill with vapor. High in the sky, sunlight will break water molecules apart in a process called photodissociation. The lighter hydrogen atoms will escape into space, lost forever. This slow leak of hydrogen is already happening today, but when Earth gets hotter, it will accelerate rapidly. Eventually, all the planet's water will be gone. Once that happens, there's no way for it to come back. Earth will be permanently dry. And here's the part that's even scarier. It happens much sooner than total ocean loss. As Earth warms, carbon dioxide levels in the air will actually start to fall. That sounds odd, since CO2 is the gas we link with warming today. But when it gets hot enough, Earth's rocks act like giant sponges, soaking up more and more CO2 from the atmosphere. The hotter it gets, the more CO2 those rocks absorb. Imagine Earth's surface as a thirsty sponge, pulling the very air plants need to survive right out of the sky. Eventually, CO2 levels will drop so low that plants can't perform photosynthesis anymore. No photosynthesis means no oxygen, no food chains, and the collapse of entire ecosystems. Scientists predict this disaster in just 600 million years, long before the oceans vanish. Life has thrived on Earth for 3.5 billion years, but it may have less than 1 billion years left. Within 600 million years, plants and animals will likely disappear. Ironically, mammals, among the newest arrivals, will probably be the first to go. After that, reptiles, fish, and everything else. The very last survivors will likely be microbes, single-celled organisms that don't rely on photosynthesis, but even they need water. Once the last underground pockets of water are gone, even bacteria will vanish. Earth will finally fall silent, but not all is lost. By the time Earth becomes uninhabitable, Mars will have drifted into the Sun's habitable zone. Its surface could become warm enough for liquid water. Mars has challenges: a thin atmosphere, harsh conditions, but we have time. 600 million years is an unimaginably long span for human technology to advance. Perhaps we'll learn to terraform Mars, making it a second Earth. Maybe we'll invent ways to shield Earth itself from the sun's growing heat, buying more time for life here. It's impossible to know what kind of breakthroughs our descendants might achieve in hundreds of millions of years. But one thing is certain: exploration is our path forward. Mars and worlds beyond may one day carry the legacy of Earth. Though our planet's time is limited, our journey doesn't have to be. With science as our tool and imagination as our guide, humanity may yet endure. Earth gave us life, but the stars may give us our future.